There we go. I'd love to take credit for that building, but I was actually born, but I was certainly nowhere near anything to do with its manufacture. But it remains an icon, certainly for me, and I think for many of us. I've done a presentation here which is far too long for the time. If you send me an email to charles@rickardengineering.com, I'd be very happy to send you a copy, because there's lots of lovely pictures which weren't unable to be put on the UB stick. But what I wanted to do is to go through what I think are some important points, and then whatever I get through, you can blow the whistle on me with 5 minutes to go, and then I'll shut up when you want me to, okay? So a few things here that are going to lead to something which I think is very important. So in 1980, when I first arrived in Australia, I got involved with Glen Industries to build sound barriers, sandwich panels, styropor panels. Styropor was actually mentioned in the Pilkington Design Guide, because you can get fantastic fire resistance with those sandwich panels. The problem with sandwich panels, apart from the difficulty of making them, is that the two skins are either in direct tension or direct compression. They're not in bending. Which means if you use the good old Pilkington rule, that you can take 6 MPa in bending and only 3 MPa in tension, or compression, not compression, but in tension, then you're very much limited by what you can achieve with these panels. And if you actually design it properly for temperature, you can get the bowing created in the panels can damn near use up all your 3 MPa. So you've virtually got no reserve for wind loading and the like. Now, when you go across the Sydney Harbour Bridge, if you ever go to Sydney, which I hope you all do, you'll find about 500 metres of my sandwich panels on both sides of the road. And they are littered in cracks because temperature and shrinkage. We didn't even seal both sides of the panels, which is something I'm going to talk about a bit more in the future, in a few minutes. Sandwich panels have been a problem. They were a problem for Pilkingtons before I ever got involved in GRC. And all I'm saying is that lovely lady who did a presentation yesterday is that I wish her all the best and keep working at it, but she needs to focus very much on temperature and shrinkage. But the point I'm trying to get to eventually is, in 1980, it was deemed good building practice and was definitely state of the art. Now we have a very different view. Rickard Engineering are out and out facade engineers as well as structural and civil, but we mostly do facades these days. And I've designed an awful lot of buildings with composite aluminium panels on them. Alpolic. Not Alpolic NC, which is the new Alpolic, which is fire resistant, but the old Alpolic, which is highly flammable. Thanks to the law of tort, and I keep ducking, I haven't yet been sued. But seriously, there are an awful lot of buildings, and at the time that stuff was used, it was good building practice to use the Alpolic panels. Which brings me straight through to UHPC, deliberately. You have to act in accordance with good building practice. The problem, as an engineer who's got $10 million worth of PI policy out there, which costs me 230,000 Australian a year just for the policy, we engineers are very, very, very focused on liability. We have to act in accordance with good building practice and all relevant standards. Pilkingtons did a fantastic job developing GRC when they did. It's incredibly conservative, which I'll come to in a minute, in terms of what they allow in terms of stress levels. UHPC has got massive compressive strength. Whoopee. We don't have a problem with compression, we have a problem with tension, not compression. So what I'm putting out there to you all is that the introduction of UHPC, which is already seemingly on a massive scale, can only be done sensibly by people with a code of practice which is not focused around individual proprietary interest, but has been subject to the appropriate scrutiny because materials with high cement content are definitely a worry compared with the contents in the GRC. We must be prudent in how we do this because we don't want any more composite and aluminium fiascos. Moving on to a few other things. The presentation this morning on polymer was fascinating. But again, I mean, I think this is a great forum. I really think it's been fantastic. Plain GRC losing 66% of its ductility/strength within 10 years, I don't think that dear old girl has had that problem. So we have to be very careful. We definitely need to be involved in R&D, but we have to be, as I just said with UHPC, there may be absolutely nothing wrong with UHPC. But at the same time, we all know that there's been a very strong conservative approach by PILCS to GRC. If I'm losing 66% of my ductility strength within 10 years, that would not suggest a conservative approach. And it certainly isn't backed up by the performance over these years. I'm a big fan of polymer, don't get me wrong, I am. But that's a comment on polymers. A couple of other things. Colour variation is definitely a big problem in the industry. In 1987, I was asked to go across to America to work with a company called GRC Texas in a little place called Waco that you've all heard of for other reasons. And when I got there, they showed me a picture of the building. And there were swinging stages on the facade of the San Antonio Marriott Hotel, which was a facade being supplied by GRC Texas. The architect had complained about the colour variation in the panels. And there were guys on swinging stages desperately trying to coat panels in the air to get a more uniform colour. So it's been around forever. The precast concrete industry has a problem with colour variation. They're very smart. Most contracts on precast concrete actually have 2 samples which are approved by the architect at the beginning of the project to say, we've got to get our panels within that colour variation, because there's really only one colour that works. It's called white. And if you go anywhere other than white, you're going to have a problem with colour variation. One of the things I might get round to showing on my slides is a building in Sydney called the MCA, Museum of Contemporary Arts. There were 6 different colours on that building: black, brown, all manner. We used a Norcor stain. I've not got anything against Norcor. The colours, the fading on those colours is huge, to the point where it's quite sad to look at it for me. But when I spoke to the architect, he loved it because it aged. He likes the fact that the building looks a bit old. But you can get 90% of your architects are going to want it absolutely crystal clear pink as it was the day it was made. So that's the colour variation. And the other one is sealing of GRC. Sealing of GRC makes sense. Polymer's fantastic and definitely needs to be embraced, but I think all GRC on the inside face and the outside face needs to be sealed. Years ago, there was a coating called Bonflon, which was very popular from Japan. Glen Industries used it on a couple of panels in Sydney, and the rules were they had to get their moisture down to under 7% in the GRC, and then they would put the Bonflon on one face and they'd seal the back. I think going forward, and this is where I'm really getting to the crux of what I want to talk about, is where does the industry go and how does it focus on the things it needs to do? Leaving aside UHPC, the rules I've followed since 1984, very, very simple. MOR 21. Divide that by 2 gives you 10.5. That's the allowance in the PILCS. This is my interpretation of PILCS. It's not actually written anywhere. But what they're saying is you will get creep of the fibres in the matrix. In that design manual in the 1970s, which was my little Bible, along with Mike Fordyce's book on GRC, and he sends his best regards to those of you in the GRC. I had no idea Mike had been so involved in the GRCA. 21 MOR. Divide by 2, 10.5. Put a factor of safety of 1.75 on 10.5. You get allowable bending stress of 6, tension of 3, shear of 1, modulus of 15,000. That's how I've designed my GRC for 40 years. The industry's got got its knickers in a twist over limit state design. I actually don't quite understand what relevance limit state design has to a material which has got a plastic range of a bee's dick. I mean, it's so short. I know it's ductile. You won't get a massive failure instantaneous. But, you know, in the 70s, we all loved designing reinforced concrete. Those are the engineers in the crowd. And we used to create plastic hinges in reinforced concrete. And we used to design for hinges and rotation. And can't go more than 30% redistribution of bending moment because you'll get too much cracking in your GRC, in your reinforced concrete. And you had to control your cracks. I've got a limit state version of my design, which is based around the LOP, not the MOR. So I come back to the fact that 21 MPa, and by the way, when I'm doing premix, I just pro-rata premix based on the spray. So if it's 13, typical figure is 13 for premix versus 21 on the on the spray. If you put your Forton in there, you can get it up to 30. And I can go on all sorts of things, tangents on that, but I won't stick to the story, Charlie. So we need to focus on the long-term strength of GRC, because I think a 50% reduction is ridiculous. But you see, the boys yesterday, the team yesterday were talking a lot about QA and control. I like to think GRC, it's gone in the mould, it's been sprayed, and it's like a railway train. There are all these little carriages of sand cement, little globules of sand cement. And in between those little globules of sand cement and polymer are the couplings that join it all together as a train. And those couplings are little bits of fiberglass, about this long. Typically, as you all know, or most of you will know, you clean the moulds, you get ready for the spray, and the spray often starts at lunchtime, and you're cleaning up by about 4 o'clock, 5 o'clock. Next morning, about 8 o'clock, the GRC might be 13 hours old, might be less. And the poor old bugger gets lifted out of the mould. You might have mould whiz on your moulds, or you might use some air to get it off the mould. That is the worst stress that GRC will ever be subject to its entire life. My pet phrase about GRC is, if you can get it on a building, it'll last 100 years. Because your material is so plastic, it's so young, that's the time when it's getting stressed. So we do coupon testing to look after our GRC. I say to all my manufacturers, and they don't do it, is you need to be testing coupons while you're actually lifting it out of the mould, or in the early days lifting out of a mould. So you get a feel for the environment in which you're making your material. If you're making GRC in Australia or England in particular, where you've got a climate that's all over the place, and then you compare that with making panels in the Middle East, where they seem to make it and stick it out in the sun the next morning and leave it there for the next 3 weeks. That's the time when the product is those couplings between the globules of GRC are working their little boo-boos off. So that's where QA comes in. And then when you start saying, oh, GRC is 21 MPa, bloody good figure, isn't it? And then we've got Forton that takes it up to 30, and we don't pay any attention to QA, you may as well forget about it. Because if you don't have the QA in your factory to control the stresses when the panels are really young, all the 21s and the 30s are a waste of bloody time. Because the panel's already been determined by how you make it. So I often think, because QA is not good enough in the industry, for sure. I mean, I've visited many, many factories, and it's never going to be to what I want to see. I mean, I talk about coupon testing during manufacture and understanding, but I don't think a lot of people understand that that's the time when it's very critical. Curing of panels, right? You need to stand them and have air circulation around rib panels because you don't want the panels to bow. Your steel frame panels, you've got to make sure that the GRC isn't gunking up on the flex anchors at the heel and at the front, because the GRC has got to be able to shrink during manufacture. About 1 millimetre per metre, I reckon, but it can be higher. And if you don't allow all these little things in your manufacturing, then we can't actually afford to reduce the Pilkington rules, in my opinion. We have to understand that there's an integral connection between QA and saying, well, Charlie, that 50% reduction from 21 to 10.5 is bloody ridiculous. I agree it is. But you understand what I'm trying to say. We've got to make sure that we understand when the material is vulnerable and what we need to do. Okay, here endeth the lesson. Let's move on and have something less bit. So things that I've designed with, how am I going, Mr. Chairman? How many minutes? 5 minutes left. Okay. Different types of panels. Steel frame panels. Flex anchors and gravity anchors. Separate flex anchors to allow for the movement, gravity anchors to take the dead load. I've done panels up to 9 meters long by 3 meters high. This is actually a picture of a panel that's being done at the moment at the IICC in India, a massive project, very sexy panel with lots of holes in it, steel frame, flex anchors. That's definitely the premier system, and certainly you'd want to use a steel frame on anything that's 9 meters long. Here's some pictures of it under construction, supplied by Al Tasnim. Thank you, Al. Okay, this is a job in Sydney where these curved panels, ribbon panels, these are a big, long, I think these are 8 meters long, curved GRC panels on a steel subframe. Here's the steel subframe behind it, quite substantial. I've only got 5 minutes, so I'll keep batting on. Here's the Museum of Contemporary Art. This is the one I mentioned earlier about the multicolours on the facade. The interesting feature about these panels was the architect was insistent that on the corners he wanted a return. Some of those returns are actually 1 metre long. And the fascinating thing about, if anyone's got any doubts about shrinkage on GRC, I had to come up with a special detail. That's a rib panel. Got a bat on a bit. Okay. This is something I'm particularly proud of, but I have to be honest and say, I think the idea originally came out of England, but this is a project I'm very proud of. Redco GRC in Doha, back in the late 90s. These panels are all a solid GRC in the Queen's Palace. And we had a rubber mould, and we made half a panel in a rubber mould. We had, and we put stainless steel pins in that half of that panel. We then took the panel out of the mould. We then sprayed the second half and lowered the first half into the wet GRC, and they've never separated. Two-sided GRC panels. These are panels made by GRC Environments in Melbourne. And they use them for all manner. Sometimes they use them as party walls between units. You know how you've got units on one floor and they want a division on the balcony? Well, we make these double-sided panels. Bathroom floors. Now I'm going into premix. Bathroom floors taken off like Topsy in China and Australia. They build a GRC floor, they build up all the walls, and then they crane in. There's a Mascot Engineering, the most successful GRC company in Australia. All they do is pits. Here's the prefabricated bathroom. That's the floor. Here's it being prefab bathroom being craned into position. Beauty of prefab bathrooms is the GRC is only going to get stressed for about 12 months, and then it's going to be sitting on a concrete slab. So I don't have to worry about long-term creep. I've done one job with pre-stress. I've heard of a company in America that does pre-stress GRC. So it's a really simple design. You've got 2 ribs. You can see the black dots down the bottom. They've got steel bars through them. It's a perforated top. And it's never fallen down yet. Okay, finally, but by no means least. When I was in the States, they were doing a job in Fort Worth. They were laying stone in the mould. They had stainless steel clips. They pushed plastic sheet onto the clips. Did I say clips? And then they sprayed up the GRC behind the stone. And then they lowered the steel frame onto the GRC and tied the steel frame to the GRC. This is the detail, which I need to put into the Australian code of practice. So here's your stone, 10-15 millimeters thick, plastic separator, stainless steel clip into GRC. And what was amazing about those panels is they followed the same process of manufacture as if there was no stone on the panels. I was absolutely gobsmacked. I stood there the first time watching this panel get lifted out of the mould with the stone facing attached to it, and it's only 13 hours old. incredible. Never been a problem. And that, have I gone too fast? I think I have. This building here is in Sydney, done with precast concrete from Brisbane. This is all the stone cladding, mechanically tied to the GRC. So you've got some GRC panels, which are no facing, and then you've got the fancy facing. Bank of China bought it 3 years ago and made alterations. We actually got to cut up some of the panels. Perfect. Never had a problem with them. Okay, very quickly, how am I going? Okay, body zone. Some of you who went to the Millennium Dome, this is the body zone, which was GRC, sprayed by Glen Industries from Adelaide, designed by Charlie on a steel frame, done by Bureau Happold, I think it was. This is my pride and joy, but the buggers have just knocked it down in Singapore. Lee Kuan Yew's dead, a 37-metre high, sprayed on site, GRC, and there's not a single joint in the GRC, by the way. I wanted joints, and Glen Industries said don't need them. There's never been a crack in it. They've knocked it down now. But this was one of the first things I ever did in Oz, was the big ram. I've also done the big prawn and the big oyster. I call myself a specialist in bad taste. Pico in Singapore are doing a huge amount of work in the zoo. So these are some pictures of that. I had to go and do it. And then finally, everyone keeps saying that, don't they, when they get up here? Robots. Take the best grade of polystyrene you can find. Cut it with the CFC machine to what you want to do. Can you see the ripples in the GRC? This is because these were 15 monuments in Melbourne that someone threw a white sheet over. They then created a 3D model of it, and the polystyrene block then had GRC sprayed on it, put on the turntable. The robot was programmed to the 3D model, and the robot went around the GRC, chip, 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 created perfect millimetre accuracy of the 3D model. Then Gino came on, had to be an Italian, didn't it? Gino came on and hand-gloved finished the GRC, and these are done like an old stonemason. These are blocks that are stacked on top of each other. And then someone said to me, Charlie, we're going to have skateboards attacking these monuments. What are you going to do? So I cored holes in the polystyrene and created reinforced concrete columns, having placed all the blocks on top. So inside those things are reinforced concrete columns to hold the whole thing together when the skateboarders start attacking it. I think I've discussed all that. Oh, one thing quickly, you've got to understand GRC isn't just about dead load and wind load, it's about building movements. I've come across facades where people are taking single-skin GRC, putting 16 blobs of concrete GRC on the back of it, and then fixing it off on the building. No! GRC panels have to have a maximum of 4 to 6 fixings. You have a gravity fixing, you have and the other fixings have got to allow for buildings deflections, slab deflections, foundation movements. That job in Manchester is a nightmare, and I don't know when it'll get sorted out. Shrinkage and temperature I've talked about. The boys talked yesterday about QA control, and then there's a lot more, which you'll find if you read that, if you Google me or email me, and I can show you the rest of the pictures. Thank you very much.